The following is the video solution from JSDT Solutions. Question 4 says, in the diagram, triangle ABC is drawn with the vertices A, which is -7 and 0, B, 3 and 8, and C, which we can see is on the x-axis. Okay, P is the midpoint of line AB, Q is a point on line AC, and AQC is a line on the x-axis. E, which is -0.5 and 2, is a point on line PQ, and we are also told that PQ is parallel to BC. Okay, so first question says, calculate the coordinates of P. So what did they tell us about P? They said P is the midpoint of AB. So we need our midpoint formula. The midpoint is, we'll find the midpoint by saying x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And now our point P, we'll just substitute those values. So the endpoints are A and B. So A can be -7, that x value, and then plus 3 over 2, and then 0 plus 8 over 2, and just simplify. So P is finally, that is going to give us a -4 divided by 2 is -2. 8 divided by 2 is 4. And that is our answer, -2 and 4. Moving on to the next question. Question 4.1.2 asks us for the gradient of AB. And these are 2 points that we already have. Also, let me just make sure to put down this point P because it's probably going to be useful in the next questions. Okay, so let's find AB. We'll just put our points down and find the gradient of this. So the gradient is equal to y2 minus y1 over x2 minus x1. You don't have to write that again. That is fine. You don't get a mark for writing the equation. Okay, because grade 11s get a formula sheet now as well. So you can choose to go in any order. You can say top minus bottom or bottom minus top. I'm just going to go with top minus bottom. So the y values, 0 minus 8 over -7 minus 3. And this is the gradient of AB. So simplify this. We can see that this stays -8 in the numerator, and we have -10 in the denominator. So our final answer for the gradient of AB is simply equal to positive, and we can see that there's a common factor of 2 here. So this is positive 4 over 5, and that is our gradient. Moving on to the next question. Question 4.1.3 says, find the size of alpha. So we can see that alpha is the angle created between the x-axis and this line AB. So it's the angle of inclination of AB. So all we need to find this is the gradient of AB, which we just previously found as 4 over 5. So to find the angle of inclination, we simply say tan theta is equal to our gradient. Okay, so we know that the gradient is 4 over 5. So we're simply going to say tan theta is equal to 4 over 5. And then to find that answer for theta, we'll simply just take tan over. So we're using the second function of tan. So this is 4 over 5, shift tan 4 over 5, and then let's just find out what that is. So shift tan 4 over 5 is simply equal to 38 point, and that is going to round up to a 6. And you can just leave it like that, that's fine. So 38.66 degrees, and that is our answer. That is the size of theta. Moving on to the next question. Question 4.2 says, determine the equation of BC in the form of y equals mx plus c. So we need to find the gradient and then at least one point that can help us to find that y-intercept. So looking at BC, BC is this over here, and we only have B. Okay, so we don't have C, but you see that BC is parallel to PQ. So because they're parallel, their gradients are the same because they're slanted in the same way. Okay, they're sloped in the same way. So we could just find the gradient of PQ. Now, though we don't have Q, we do have E. What did they tell us about E? They said that E is a point on the line PQ. So we can use P and E to find the gradient of PQ. Okay, so let's go. We're just going to say, to find this gradient of PQ, we'll just say that the gradient of PE is equal to the gradient of PQ. And we also know, of course, that's going to be equal to the gradient of BC since those lines are parallel. I'm just stating this initially. Okay, it's equal to the gradient of BC as well. So let's use P and E. P was this point. We'll just put the points down first. Okay, so the gradient of this line, PE, is equal to y2 minus y1. So we can say 4 minus 2 over x2 minus x1, which is negative 2, minus negative a half, which becomes plus a half. So in the numerator, we get 2. In the denominator, we get, that's going to be negative 3 over 2. Okay, so negative 3 over 2 divided by negative 3 over 2. And if you use a calculator or you use tip and times, if you are dividing by a fraction, you can simply just switch the numerator and denominator and then turn this division into a multiplication. So that's just going to give us negative 4 over 3. Okay, so that's the gradient of PE. And so therefore that is the gradient of BC as well. So we can tell them that the gradient of BC is simply equal to negative 4 over 3. And to find the equation now of BC, we need one point that lies on BC. So their gradients are the same. And now to find this equation, you can simply use B since this lies on BC. So that's 3 and 8. So this is 3 and 8. And you can either use y equals mx plus c, or you can use this formula. So we can say y minus y1 is equal to our gradient, which is negative 4 over 3, times x minus x1. And our y1 and our x1 are the points we're substituting. So that is 3 and the y value is 8. So y minus 8 is equal to negative 4 over 3 times x minus 3. And we can simplify. So this is negative 4 over 3x. And that becomes positive. Well, if you have negative 4 over 3, right, and you're multiplying by negative 3, in the numerator and denominator, you see those cancels. So we just have positive 4 over there. And then if you transpose the 8, it becomes positive 8. So that's 8 plus 4, which is 12. And so y is simply equal to negative 4 over 3x plus 12. And that is our answer. Moving on to the next question. Question 4.3.1 says, calculate the length of AC. So we didn't have C, but we do know the equation of this line BC now. And you see that C is on the x-axis of this line BC, meaning this is the x-intercept. Because it is the x-intercept, we can simply find it by making y equal to 0 in this equation. So just using the previous question's answer. Okay, so we make y equal to 0. And in this case, you see this is negative. We can just transpose it. So it's now positive 4 over 3x is equal to 12. And to solve for x, you can divide both sides by 4 over 3 or multiply both sides by 3 over 4. So 3 over 4 and 3 over 4. So that is now x is equal to, we can see that 12 and 4 have 4 in common. So divided by 4, we get 3 there. Divided by 4, we get 1 there. So that's 3 times 3, which is 9. You can also use a calculator. So x is equal to 9. And now we know what c is. So c is this x-intercept 9 and 0. And we just need a so that we can find the length of AC. So a, okay, is negative 7 and 0. If this is 9 and 0, this is a horizontal line. You don't have to use the distance formula in this case because it just means that from the origin, you went exactly 7 units to the left to get to A and exactly 9 units to the right to get to C. So 7 plus 9 would be the length of AC. Or you could have seen this as the higher x value minus the lower x value. So to find AC, the length of this horizontal line, AC is equal to positive 9 minus negative 7. Okay, so that is 9 plus 7, which is 16. And so it is 16 units, and that is our answer for the length of AC. Moving on to the next question. Question 4.3.2 says we need to find the area of the trapezium PBCQ. Okay, so PBCQ, and let's just highlight that first. So that's from P, B, C, and Q. Okay, so we need to think about this. You see, This is a trapezium. We could use the formula to find the area of a trapezium, but in this case, you see, the trapezium needs to have a height, a visible height, and then we can actually do that. So let's say our trapezium looked like this. Then we could have found the area of this trapezium by looking at the top part, the bottom, and then the height. Okay, the perpendicular height specifically, that's over there. And in this case, we would find that area by taking the top plus the bottom, and then just say divided by 2, and then multiply by the height. And then that would be it. But we have a weird scenario here because we can't see any clear visible height. We can't see any perpendicular lines. Okay, we could find out whether we do have perpendicular lines because we have the gradient of AB and BC as well. The gradient of AB we found in the second question, which was 4 over 5. And if you take 4 over 5 and you multiply by, let's see, the gradient of BC, which we already found. The gradient of BC was negative 4 over 3. Okay, so if you multiply those, you can already clearly see they're not going to give you negative 1. If these lines were perpendicular, like they formed a 90-degree angle, then the gradients multiplied should give us negative 1, okay, because that's a property of perpendicular lines. So we clearly can't really use that, and we can't even find the area as a trapezium. But look at what we could do. We could find the area of triangle ABC, and if you subtract that area, that entire area, because it's going to be everything here, and you say minus the area of the triangle APQ, then you'll be left with the area of this trapezium. So in this case, it's just best to go with this. So we're going to find the area of triangle ABC and then minus the area of triangle APQ. So let's find them separately, ABC and APQ. Okay, so these are the two triangles we'll focus on. So in this case here, this is how we can find it. To find the area of a triangle, we say a half multiplied by the base multiplied by the perpendicular height. So in this triangle ABC, okay, where's the base? We can take AC as the base, and that is great because we already have the length of AC. And then where is the perpendicular height? Well, you can't just say, oh, okay, maybe it's BC. That's not the height. That's not how high this triangle is. You're going to have to go from the highest point of the triangle, and we're going to go down to this base. And that height needs to be perpendicular to the base. So we can see that the height here is exactly how many units? Okay, from the ground, from the x-axis all the way up here, we went how many units up? We went 8 units up. That's why B is 3 and 8, okay? 3 to the right and 8 up. So it's 8 units. And so that's the height. We know the height and the base of triangle ABC. Let's put that down. So the perpendicular height is 8 units, and that base AC is 16 units, which we found previously. And now let's look at the triangle APQ. So with triangle APQ, we can see that the base would be AQ. Now, how do we find AQ? Okay, you're going to have to look at this bigger triangle because we have a specific theorem going on here. So do you see that initially they've given us that AP is equal to PB. So we have P as the midpoint. And then these two lines are parallel. Okay, PQ is parallel to BC. That means that we can use the converse of the midpoint theorem to conclude that AQ is equal to QC. And of course, that would mean that BC is twice the size of PQ. But we don't really need PQ, so it's still fine. So if we have the full length of AC and we know that AQ is equal to QC, it's just half the size of AC. This is using the converse of the midpoint theorem. So let's get AQ, and we can just say that the length of AQ, that base of our triangle, is equal to half of whatever AC is. And we knew that AC was this base, okay? So that's 16 units. This is AC. So if this is 16, it means that AQ is simply 8 units. Okay, so we have that there. And of course, if this was Euclid, we would say this is because of the converse of the midpoint theorem. But this is not really Euclid. You don't really need those reasons. Okay, so now that we have that down, what is the height of this triangle, okay, of APQ? The height of triangle APQ, you're going to have to go from the highest point of APQ down to the base and ensure that the line is a line perpendicular to the base. Now, funny enough, you can actually use the area rule here. Okay, the area rule you learned in trigonometry, okay, 2 and 3D trig. So here we're just going to use this. Okay, so we know that P is -2 and 4. So that just means that the height of this triangle is, okay, that y value of P, which is 4, because to get -2 and 4, you went 2 units to the left and 4 units up. Okay, so we know it's exactly 4 units. So that is the height of PQ. So the perpendicular height is 4. And now we can go ahead and find this. So the area of triangle ABC, you can actually just find it together. That's fine. So we'll say that the area, to find the area of this trapezium, PBCQ, we simply say a half multiplied by the base. Okay, so we're taking the area of, it's better to just say the triangles, the area of triangle ABC minus the area of triangle APQ. And so this is equal to, we're just going to say this area of triangle ABC is found by saying a half multiplied by our base, which is AC, and that's 16, multiplied by our height, which is 8. And then we're going to say minus the area of APQ, which is a half multiplied by the base, which is AQ, that is our base, and that is 8 units multiplied by the height of 4, the perpendicular height of 4 units. Okay, and let's just find the areas separately first. So this area will give us half of 16 is 8, and then 8 times 8 is 64. And then we have minus, so these are in squared units, and then we have 16. And then it just is equal to 48. So this is 48, I'm going to say units squared. And that is our answer. And that is it for question 4.